Hey guys, BuildZoid here, and so yesterday I got the first LN2 delivery in a very, very long time. Um, and the thing is, I think it's been over a year now that I last ran LN2. So, yeah, anyway, so I got a delivery. The thing is, I have four doers. So I have a 30 liter, another 30 liter, and then two 35 liters. And so I got 130 liters of liquid nitrogen, which is why there was that poll on the channel community tab where I was like, how many liters should I buy? Like those quantities are literally just lined up by how much capacity I have across the four doers I have. Because I wasn't really sure if I want to buy a full 130 liters, because that is kind of a lot of liquid nitrogen, and I pay £1 a liter. £1 as in the British currency. Um, but yeah, anyway, so I bought 130 liters. And since I hadn't benched in like forever, I decided, you know what, I'm just gonna run. Like, I didn't do a video of any of it because I wanted to actually like get some scores done and have fun doing it instead of worrying about being entertaining on camera. So there was like the thing is what basically not having the camera on leads to is me sitting there doing the same freaking thing over and over and over again. Um and like being okay with it, cuz there's some, like, especially the 3960X was just the most annoying thing I run in a very, very long time. Like, horrible CPU to work with. Anyway, we'll get to that. So, yeah, I got some pretty good results. These aren't all the things I ran. I also ran an FX8 320E. But yeah, that didn't make it to the front page because it wasn't really that great. Um, but yeah, let's go through this in no particular order. So, first up, I guess, Geekbench 3 with the 3960X. And so the 3960X, well, let's just go through the score. So this is the Geekbench score. Geekbench was kind of annoying on the 3960X because I'd had to rerun it a bunch of times before it got this score. Like, these settings would occasionally spit out like a 131. And if you ran it enough times, it would spit out like a 133 or a 1332. Like, I was getting like a 1332, and then if you ran it again, you'd get a 133, 131. So then you have to restart. Like, the first run after booting up would normally be the best. So basically, if I didn't get the first run on the first attempt, it was just like have to restart. And that doesn't sound like a big deal, except for the part where the 3960X absolutely hates booting. Like, I have no idea why, but turning on is way more difficult than anything once you get into the operating system. Like, that was the biggest challenge for me, was like getting into the OS. Um, so yeah, that was super frustrating. And there was other sketchy things about the setup. So yeah, but this is a first place score. Um, I'm still not sure about that memory score, but the thing is, I can produce that score pretty consistently, and I'm not running maxmem on this run, right? Like, I don't need maxmem for 4400 CL16. This was with the Team Group Extreme ARGB memory sticks because they're the best Samsung BDI I currently have. So I didn't really feel like working with a different kit, because why would you use slightly worse sticks? It's not like I'm doing particularly insane settings, but it's just like, if you have a really good kit, you can do good settings without having to worry about it. So these settings aren't even what I would consider particularly amazing, but at least I didn't have to like fight the memory sticks into submission on that. So that's why I went with the Extreme ARGBs. The motherboard was just the MSI Creator TRX40 because I don't have another TRX40 motherboard to run. Um, and I guess the motherboard might be part of the whole booting up was such a nightmare, but I've not run any other TRX40 motherboards, so I don't know if that's like a motherboard thing or if the CPU just like hates turning on. The worst part about Threadripper is, like, even when it's not posting, the post process on it takes for frickin' ever. So I think, like the thing is, the CPU did chug liquid nitrogen, but I think I spend most of my LN2 just like trying to get the CPU to turn on, because that was the biggest problem. Was just like, can we please boot? But anyway, so yeah, I got the Geekbench. I don't know why that was open. Let's do the Threadripper scores first. Where's the last one? There's Cinebench. So, Fly Cruncher, um, I like this benchmark. This is a cool benchmark. It's quick. It's also very, very memory intensive. Um, and it's also pretty easy. Like the thermal load is pretty consistent. So it was actually kind of like it was relatively easy to handle, but we'll talk about that some more later. So yeah, still the same setup. Actually, exact same settings as Geekbench. I didn't really like the thing is like because booting was so incredibly difficult. Like I think I could have probably run Geekbench at 4.9. Because Geekbench is actually like the peak power draw on Geekbench is quite high, but the duration of that power draw is relatively low. So I could have probably run 4.9 for Geekbench, but for this is consistent. Like this is 15 seconds of basically full power consumption. As far like, and I didn't have a current clamp on it, so I'm just going by like how the LN2 pot was responding. Um, yeah, Geekbench swings the power consumption all over the place. This doesn't, as far as I can tell. And then Cinebench is kind of the same thing. It really doesn't change the power draw too much. And I got second for Cinebench, which isn't too bad, right? And again, I was just running the same settings as always. So that's kind of that. Let's take a look at the actual setup. So the Threadripper setup was very sketchy. Very, very sketchy because I actually don't have a Threadripper compatible LN2 pot. I don't have a any Threadripper like compatible mounting hardware. So what was going on was I did this, and you can see that this set of standoffs here is like at an angle. And the whole reason this is there isn't actually to like pull the LN2 pot down. It's not putting any pressure on the LN2 pot because the Threadripper socket uses M3.5 threads, which is just like the hell. Nothing uses an M3.5 thread. Okay, like GPUs regularly use like M2 and M2 and a half. Motherboards are normally M3. There's some LN2 pots that use M4 threads. And I think the X299 socket uses M4 threads, and the X99, X79, like Intel HEDT socket hold down uses M4. And then there's Threadripper, which is M3.5. So I don't have any M3.5 anything. And so yeah, basically this right here was just a case of like I need the LN2 pot to not slide off the CPU. That's what this is for. So it's not actually like putting any mounting pressure down. The pot is just being held, it is being restricted in its movement because my desk isn't level. So if I leave the LN2 pot on there, it'll just slowly slide off to one side. So this was literally just like a movement restriction on the CPU. And because the standoffs are at a like angle, they actually catch on the threads. So they're pretty in there. But yeah, this is really not ideal, which is why I think under some of the scores I left a comment like thanking gravity for, thanking the Earth's gravitational field. Because yeah, this was only, like running it like this is only possible thanks to gravity. Because that pot isn't actually attached. It's just kind of sitting there, and these are restricting it to sort of stay there. I was kind of considering maybe using zip ties or something, but the problem with zip ties and low temperatures is that they're made of plastic, and there's a good chance they would like pop if they get too cold. So, and another thing is like the Threadripper mounting plate. It doesn't go through the board. There's no hole there. So you couldn't really put a zip tie through that anyway, so you'd have to like run the zip tie to like a motherboard, like a motherboard mounting hole like this or something. And then you'd be like flexing the whole board, and that's really not great. So yeah, thank you Gravity for the support. Also, the LN2 pot is a Kingpin cooling Venom. It's not a T-Rex, it's a Venom. The Venom is the Venom looks like this. It's basically just a bunch of holes. It's not very controllable. In fact, I'm really surprised that this went so well on the 3960X, and I think most of that is down to the fact that the 3960X put out so much heat that the Venom wouldn't overpower it. Because I tried to use the Venom on like X99 at one point, and it was a nightmare because if I filled the pot, the temperature would rapidly start dropping, and if I didn't fill it, the temperature there's no way to drip feed this, because if you try to drip feed it, you're just going to fill up the center hole, and there's no surface area there, so nothing happens. The temperature just keeps going up and up and up and up. And if you hit the whole thing, then yeah, it starts actually being able to dissipate heat, but it dissipates it so fast that, well, on X99, it would just cold bug you immediately. So really annoying. Like, I really wasn't sure that this would be a good idea. But it turned out to work really well because the 3960X, I didn't have any power monitoring hooked up. But the thing is, I could fill this up and the temperature wouldn't go down. So it was like, great, okay. So basically for a benchmark, what I would do is I'd have it like filled like this. Not literally full. You don't actually want. You just want to submerge like the copper structure, right? Because the aluminum extension on top doesn't do anything for thermal transfer. So having liquid nitrogen in contact with the aluminum is just wasting liquid nitrogen to basically the atmosphere because that thing isn't cooling anything. So you just want to cover up the copper structure. So anytime I was running a benchmark, and this is off of the AM3 runs, because yeah, the Threadripper, like, it was constantly empty. I wasn't running it full pot. Yeah, you'd just fill it up, and then if you were running like Cinebench, I'd start Cinebench at like minus 137, and I'd fill it up, and the temperature would level off at minus 140, and then I'd just have to time it that my last pour would work out that the it would burn off before Cinebench finished, which is pretty easy to do. So yeah, I wasn't like the temperature wasn't swinging around too much. It wasn't super controlled. Like, I've achieved better temperature control with other LN2 pots on different platforms, but yeah, for this it was fine. Also the cold, like, the thing is, the big problem for me with the Threadripper was like there was a cold bug somewhere below minus 150. And I say somewhere below minus 150 because the defining feature of the 3960X throughout the entire session was that it's super inconsistent. Like, the thing would just not work and sometimes work for no apparent reason. So sometimes I had some runs where I was at like minus 155 and it was fine, and then other times you'd go below minus 150 and it would just up and like stop running. And I'm not sure why it does that. It just kind of did. So that was super annoying. But yeah, the thing is like the LN2 pod actually worked out okay. But it's not because it was like particularly well controlled. It was just kind of like it was like the CPU and the LN2 pot were matched up well in terms of power consumption versus heat dissipation capabilities. So yeah, it wasn't as like I was expecting it to just be completely out of control, and no, it was actually kind of okay. Another advantage to the Venom is that it's really light. It doesn't really have a ton of mass. And so it warms up really quickly, and also you can shove the hairdryer like way down in there because of how open it is. So it was actually really easy to pull up. And the reason why that's significant is because the platform had a cold boot bug between, and I say between because it was literally like there wasn't a temperature where it worked. It was like sometimes I'll boot, sometimes I won't, and it was between like minus 135 and minus 105. So between minus 60 and minus 105, the system just doesn't post. It literally doesn't post. I never got it to boot at those temperatures. No point even trying. At a minus 105, it sometimes turns on, but it doesn't really like it. Like, there was a couple runs where it would turn on at minus 105, but it wasn't really like that was honestly surprising. I didn't expect it to work. At minus 120, it would work like 50% of the time. And then sometimes I had to boot it all the way down at like minus 130 and a lot of the time at like minus 125. So the boot up temperature was just completely all over the place, and I never figured out why. Like, it was just kind of like I'd just sit there if I restarted, and I'd restart at like minus 135 or something, because that's normally where I'd start my benchmarks. And then I would just let the temperature crawl up or down, or like just swing the temperature around while trying to reset the system. And eventually it would just kind of turn on. So that was super, like, not fun. Because, yeah, I was just burning off tons and tons of liquid nitrogen trying to get the damn thing to turn on. And then the really annoying thing was that once it turned on, okay, somewhere in the minus 120 range, the Windows login process actually puts a pretty heavy all-core load on the CPU for a little bit. So I actually had to pretty quickly pull it down as Windows was logging in, or it would crash again. So, so it was like as soon as the post process finishes, it was hit it with LN2 so that I could get the Windows screen at like minus 130, so that I could get through Windows login. Then you could run benchmarks at like a minus 135 to minus 145 ish. Like, yeah, it was all over the place. So, yeah, I didn't really like this very much. Like, on one hand, it was like it was neat that it was kind of involved compared to the FX benching, where you just kind of sit there and make sure the LN2 doesn't all boil off. But because the FX CPUs run at full pop, but the thing with the 3960X is like there wasn't any method to it, right? Like it was like rolling dice basically on whether or not it'll turn on at some temperature. Um, And so I really didn't like that because it didn't feel like I was doing anything clever or like I wasn't fixing a problem. Like the same problem I started with, which was the system doesn't like posting very much, is exactly what I ended with. The system doesn't like posting very much. And it's just kind of like, yeah, um, that's not great. That's as far as I'm concerned, that's not how this should go. Like you should have a method to getting the system to run properly, but it never ran properly as far as I'm concerned. It made scores, but as far as like running reliably and consistently goes, it was a mess. It was a horrible mess. And the same thing kind of applies to the Geekbench score where it was just kind of like, because I think my very first Geekbench run was like 13 to 75. Yeah, 132,000 something. And then I got a bunch of 131,000 score. Well, I got like a. Oh no, I got a 13375. And then it crashed right as I was like gonna take make the save the score, which it did twice to me. It did that. It did it also on Y Cruncher. My very first Y Cruncher run, I got a 1576, 767, which was already like the top score for the 3960X. And so I got really excited. And right as I was about to like do the thing to save the score, it just shut down. And I don't think it cold bugged because it was at a temper like it was actually like pretty warm, especially since like it locked up several seconds after the benchmark finished. Like normally if you finish a benchmark too cold, it'll just lock up immediately as the load comes off. But here it was like 10 seconds later it just randomly shut down, which admittedly I've had Ryzen CPUs do that even at ambient, where they'll just like you'll be doing something and then it'll just black screen out of nowhere. So, and I still haven't like, and I think it's just a BIOS thing. Like certain BIOSes just seem to do that. So yeah, just Ryzen things. Lovely platform. So Y Cruncher did that. My best Geekbench score did that. I think this is still slightly lower than the best score I had, but it was just like, and this is the best score, so like anybody's gotten, so I'll roll with it. Um, but yeah, so that was very fun to deal with. Um, so yeah, that was the 3960X, and I can't really comment on the motherboard or anything because I've not run any other motherboards. The memory sticks did a good job, so that's neat. Can you see it? Oh, I don't think I have a photo of it, but this memory stick ended up freezing over, and it was fine with that. And also the insulation job on the motherboard wasn't really like I really rushed it. So I'm kind of surprised that I got as much bench time out of it as I did because I ran it for a while. Um, but yeah, like I didn't really because I didn't feel like pulling off all the heat sinks and then like for the dim slots, what you should do is like tape over the dim slots and then mash I use Plastidip, which is basically the reason I use Plastidip is it's basically the same stuff as liquid electrical tape, and in fact the company that makes Plastidip also makes liquid electrical tape, and if you compare the like property list of both of those products, they're the same thing. Like that's why I use Plastidip because you can get it in more colors as well. So anyway, yeah. So I didn't really do the insulation, particularly well. So I'm kind of surprised that it ran for as long as it did. Um, and anyway, let's move on to the FX scores because the FX scores, while in like arguably simpler in terms of what I was doing, there was at least a method to it. Like it wasn't like this where it was just kind of like, let's see if it turns on or not, and then runs. So yeah, the 3960X was just like a random number generator in terms of in terms of functionality. Not like yeah, this was a mess. But good scores. FX8320E. This was actually the first CPU I ran, and the reason I ran the FX8320E first was just kind of like, well, I didn't really have a specific reason to go with this chip, but I started with FX because AM3 Plus on LN2 is basically like AM3 Plus on water cooling. Like, if you get your insulation right, it really isn't any different. There's no, it's super easy. There's no, you don't need to, there's no, it doesn't want to post for no reason. There's no, you need to set these voltages super precisely. Like, the chips just work at minus whatever. They also run completely full pot. So, that's what's really cool about AM3 Plus. Honestly, I think if you want to like start getting into liquid nitrogen overclocking, AM3 Plus is the best for this because the CPUs are relatively cheap. So you have all the different FX chips. Then there's also you can run Phenom 2s, right? AM3 Plus motherboards take Phenom 2s. They take Semprons. Any DDR3, I think basically any DDR3 CPU that went into the AM3 socket, it'll also run in AM3 Plus. So you have like a huge selection of CPUs that you can run on a single motherboard. The motherboards are relatively cheap. Admittedly, a lot of the AM3 Plus motherboards are also terrible. The one I was using isn't really a massive exception to that. I was using the Gigabyte 990FX gaming, and I like the board, but at the same time, it's not a particularly good board. So here's the board. Actually, wait, do I have a better picture of it? Ah, there we go. So the main reason I like the board is it has a post code. Very, very helpful. So it has a post code, power button, reset button, clear CMOS button, and that's the main thing that I like about it. Things I don't like about it, the VRM. The VRM on this thing is literally the same VRM that you'd get on a 990FX UD3. So the big problem with this is it literally can't run all-core workloads on the 8-core chips because it shuts down. And that led to some interesting things with the other CPU that I did CPU-Z validations on. But the A320E wasn't really like too much of a problem. So yeah, this was just pull down to full pot and then just kind of sit there and fiddle around with BCLK and ratios. So the reason why you have to mess with the ratios is actually FX chips. Not all of them will be able to run the really high ratios, like 28. Like I think this chip didn't even like 28x. So that's kind of the thing is like certain ratios, and you need to check this. Is that you basically go and you like at a low BCLK, so not like 300 that I'm running here. Well, that's 299, but at a relatively low BCLK, you just crank the ratio all the way up, basically. And what you'll normally find is a lot of the higher ones don't work. As in, you just set the high ratio and it just locks up immediately. So, because of that, the first step is figuring out what ratios are actually usable. With this CPU, it was 27 times. Also, it sometimes helps to run like lower ratio, higher BCLK rather than lower BCLK, higher ratio. It's just a thing with AM3 Plus if you're going for validations. And so yeah, so that's one thing is like you kind of need to know what you're like need to be a bit like the CPUs in like it's not some chips will literally just kind of do 8 gigahertz on all their cores at the same time. You don't really have to do anything. A lot of chips, at least all of the chips I've worked with, you kind of need to actually know what you're doing because they don't just work. But anyway, what did I want to pull up? The big thing for FX chips is this right here, which this right here is PS check, also easy tune. And you'll notice I'm also running 4 cores, 4 threads on this. I'm not running, the whole chip. And this is the main reason the 4-core, 4 threads thing is the main reason I was using the 990FX Gaming from Gigabyte, because I do also have a Asus 970 Aura board, and that's a pretty solid board, better VRM. For multi-core benchmarks, it's better than the 990FX Gaming. There's just one problem. It doesn't offer 1 core per module mode. So The reason why you really want one core per module mode is that you have two cores in each module, and they're generally like within a module. You're probably not going to see too much variance, but with most of like with my first FX 9590, because at this point I just don't bother with fully enabled chips. Like if you're going for validations, you're not running benchmarks. Who cares about the performance? So, but with the very first FX 9590 that like was the first chip I ever got over 8 gigahertz, that chip, um, the first module, I think it was the first module, might have been the second, but one of the modules was the best, and there was one core in that module that was like 80 megahertz worse. So you really don't want to be running both cores at the same time, because one of them is maybe going to suck and it's going to drag it down the best core. Also, running one core per module gives you better thermal density, right? Because, well, you have less cores running in the chip. So running 8 cores on FX is just kind of like if you're really lucky, I guess it'll work. But most of my chips, like the A320E was really extreme in this with the core to core variant, well, module to module variants. I didn't individually test the cores. I don't believe in doing that. There's no bloody point. I'm gonna run one core per module anyway. But yeah, so this chip, the first module was terrible. It was like 7.3 gigahertz max on the first module. And then the second module was actually the module that I pushed to 8 gigahertz. The third module was like, actually no, I think it was the third module. I think it was the third module. Anyway, but there was one module that was like 7.3, one was like 7.6, and there was one that was like 7.8. And that was all at the same settings that the best module uses for 8 gigahertz. So there's a huge variance in quality between the different modules, and it's just like you got to get PS check. Like you got to get this, because you can see I'm running like 3 of the modules at the lowest possible frequency, which also reduces the thermal density, which also like that also helps. Just running lower clock speeds reduces your power consumption. So even especially at like the insanely high voltages, this actually helps quite a bit. Even if you're not like, if you're idling, like just running the CPU at a lower frequency saves you a bunch of power. So yeah, this was a big thing for getting the 8320E to do 8 gigahertz, because if you didn't do that, it would get stuck at 7.3, because that's where the worst core tops out. Right, like this is a 7.3 all-core chip. Actually, it's not even like if you ran an actual benchmark all-core, then it probably wouldn't even do 7.3. And that's one core per module. There's maybe a core on there that only does 7, right? So this chip is a mess. Is basically what it is. Like the quality is just completely all over the place. Which I guess makes sense for an 8320E, right? Because this is like the energy efficient variant of an FX 8320. But yeah, so that was interesting, and got the top score for that. So I got 2 8 gigahertz validations in yesterday and earlier today. That was when I did the 9590. But yeah, so top score for this CPU. And I want to test, like, I still want to do way more FX chips. Like this, like the 8 gigahertz FX thing is just super fun in my opinion. Like it's nice and simple. There's a method to it. You don't sit there wondering why the system doesn't want to post its settings that just worked. Like AM3 Plus is awesome. Also, if you have a good motherboard, you can actually run multi-core benchmarks, but unfortunately, I can't do that with the 990FX Gaming. I can run multi-core like Phenom 2s. I've used it for that. Up to quad cores. I've not tried to run a 6-core. I assume a 6-core would shut down the VRM again. But anyway, so the A320E wasn't super difficult or anything. The biggest problem really was just Gigabyte's EasyTune software, which this thing likes to crash. Like it likes to lock up the whole system for no reason. And that was like the biggest inconsistency, but that honestly, it's not as big of a deal. And there is a workaround for it that I must have, like, I figured it out. Like the thing is, I forgot what the workaround is. There's a workaround for getting EasyTune to not randomly crash on you when you change when you try to apply your first set of settings, but I've forgotten what that is. I think towards the end of the FX 9590 session, I kind of figured it out, which is just, it should probably just be a matter of hitting the reset button. but before you try to change any settings, but I'm still not 100% certain on that, so I need to test that more because yeah, EasyTune is a pile of trash, and I really wish I had Gigabyte Tweak Launcher, but there's no Gigabyte Tweak Launcher for AM3 Plus, or at least I'm not aware of any version of Gigabyte Tweak Launcher for AM3 Plus, and so I was stuck using this pile of garbage. Which, like, the main problem there is the inconsistency. It's not like if it works fine. If it doesn't work, the whole system locks up. So that's not super fun. But yeah, a lot of the time, if it works, it just kind of works for multiple boots. So yeah, like once I got it working, like getting to the final validation frequency. Wait, what's this? Oh, that's just the Threadripper again. The final validation frequency of 8343. And this CPU has more in it. The CPU definitely has more in it. The issue is the motherboard is very upset about running it. So you might be thinking, what's the difference between an FX 9590 and an 8320E? Where's the 8323? And the 8320E, right? They're both 8-core CPUs. Why would there be such a difference in terms of trying to make an 8 gigahertz pass on the 9590 compared to the 8320E? The leakage is the difference. That 9590 pulls an absolutely stupid amount of power. Like this right here, it's at minus 186.5 at 2 gigahertz. That's like, okay, you can't really, like, it's at 2 gigahertz. All cores are at 2 gigahertz. And admittedly, this is at like 2.1 volts, but it's at minus 186. The A320E doing the exact same settings would be at minus 188. So this chip was just leaking like ridiculous amounts of power. It was so bad that I had to boot the chip at like 2666 FSB, well, BCLK, not FSB, but yeah, I had to boot at like 2666 BCLK, and then with 1.76 volts, because if I tried to boot a higher BCLK, and there was also some weird software issue where if I set the CPU ratio below 25, it was just like bug out in the operating system. So I had to boot at 25.5 at least. And the problem is 2660, like anything higher than 2666 at 25.5 would require more vCore to get through the Windows login screen. And the Windows login screen, again, applies a relatively heavy multi-core load. So with only 4 cores enabled, this chip at 1.8 volts logging into Windows would crash the VRM. Like, it would trip the overcurrent protection, which is just like, yeah, so the motherboard was really not having this because this chip just leaks so much power. Like, this thing is a freaking Calander, not a CPU. But the thing is, there's one amazing core on it. Like, that first module on that chip is absolutely incredible. This is from that session. That was earlier today. A big problem actually with the running this platform is that this area of the board freezes over. So sometimes, like, it'll stop restarting properly, and that's just this area freezing over. And sometimes it doesn't restart because the VRM tripped over current protection, and when that happens, the rest of the system just kind of hangs. So basically, I do want to push this CPU further because I'm certain there's more in it. It's just this motherboard was not having it anymore. Like, that chip is just absolutely insane. In terms of how much power it pulls, in terms of like how hot it runs. And also in terms of the frequency it can achieve, right? Like that did 8.343. I'm pretty sure I can get at least 8360. Because the thing is, I could get to 8378, and if I was just sitting there on the desktop, it was fine. I could sit at 8378 or 8380, something like that, just fine. I couldn't save a file, right? Because the thing for the CPU frequency is you have to save a validation file so that you can upload it to over here. And I couldn't save the file. 8380 wouldn't save. And I think on one side, I think it was the motherboard. On another side, I think it just like this chip's. I think it mostly was the motherboard at that point, where it's just like, yeah. But luckily, I have another 990FX gigabyte board that I'm working on. Well, the plan is to basically mod the crap out of that board so that not the OCP, because that board should just have a stronger VRM to start with. So it's like, how do you solve a VRM issue? You just get a different VRM. But the thing I'm wondering about is actually the voltage regulation, because I think what I was starting to notice when I was doing this is that actually going through PS check and like cranking up the core frequency, it would sometimes like I think so I'm not sure. I've done a video showing this. I can't remember which video it is right now, but I've shown this in a video. On Intel CPUs, when the when the core ratio changes, it causes a really nasty transient. And I'm pretty sure the FX chips also do this, except I didn't have an oscilloscope hooked up, so I couldn't see it. But the thing is, I was kind of like, the thing is, this is FX. It's super, it's not very high maintenance in terms of running really cold. So what I was messing around with was like going up to the full ratio and then raising the BCLK instead of raising the ratio again, because if you change the ratio, then, you trigger the whole ratio change transient, assuming that it does that. I'm not sure, but I need to check that. I think it does. Because pushing the BCLK around was actually seemingly more stable than trying to push the ratio around. Even with like using PS check to flick through the different ratios, it seemed to be more stable if you just went up to the full ratio and then raised the BCLK up instead of, screwing around with the ratio. So one of the things I'm wondering about is like, what does it look like when this chip goes, through a ratio change? And is there anything I can do to help with the voltage regulation during that scenario? Because damn it, I want to be able to save that freaking save file. Also, I want to see what kind of load what the save file, saving the CPU's evalidation actually does to the power consumption, or more like not the power consumption, the oscilloscope. What does the oscilloscope show? Because I have a I have a suspicion that the reason I couldn't save was actually the transient that hit. Um, So that's something I want to mess around with, is just like build a 990FX, like upgrade the UD, because this is a 990FX gaming. I have a UD5. The UD5 uses a different VRM from Intersil. It's also a 4-layer PCB, so the power plane's probably not that great, but I have ideas for solving that. And so, yeah, the plan is to see if like I can't build a UD5 that's just like way better at both power delivery and voltage regulation than my 990FX gaming. And the reason I want to keep using a Gigabyte motherboard is just the one core per module mode is super important. It's just so much better than well, any other core configuration as far as I can tell. I guess also you could run like one core only. I need to try that with the 9590, just one core only. I might have forgotten that that's a thing. Yeah, so I'll have to check that. So there's more room in that chip. But I think the next time I'm running it with a better board. And one thing I want to mess around with is, as far as I know, multi-layer ceramic capacitors don't respond particularly well to super low temperatures. So one of the things I'm wondering about is like, maybe if I just mash a bunch of polymers into the socket somehow, it'll maybe help. So yeah, there's just a bunch of stuff like that I want to mess around with. Like, I basically want to build the ultimate validation motherboard. Otherwise, I could also use like find a Crosshair 5 formula. The original formula, not the formula dash Z, because the dash Z doesn't have the one core per module mode, and that's super important to have the one core per module mode as far as I'm concerned, especially if I want to try more CPUs. And speaking of more CPUs, I do want to try more CPUs. Like there's one there's the 9590, and I think I can eke out 8380, maybe even 8.4. If like I also need to figure out something for the cooling. I'm gonna have to lap the CPU. The LN2 pot's lapped, but the CPU is just stock IHS. It looked reasonably flat though when I pulled off the LN2 pot. Like the thermal paste wasn't super screwed up, so like yeah, so I think the chip's not too bad. I also might want to mess around with maybe using a different thermal paste. I did all of these validations on Arctic MX4, and honestly, it seems to work okay. But I'm not sure if it's like at least on par with KPX. The thing is, like, with the A320E, I don't think it was that big a deal because this chip doesn't pull anywhere near as much power. Like, it's crazy, but yeah, like saving a file, this thing doesn't pull anywhere near as much power as this does. And so I think this chip might have actually been a bit more upset with the thermal paste. So, different thermal paste. Like, I want to rerun with like different, hopefully better thermal paste. Maybe the thermal paste won't make a difference. Lap the chip. Try build a motherboard with a better like voltage regulation, because this is a 4-layer PCB. Which is probably not helping the power delivery at all. And then of course there's the overcurrent protection tripping, which is like I'd like to be able to boot at like 2888 FSB BCLK instead of 2666. Um, so yeah, there's just a bunch of little optimizations I want to make to this to try get it even further, and then also more CPUs. Like so far, I've run two 9590s and an 8320E. I also have a 6350 that I still want to run. But other than that, I also would like to run like a 9370, 8350, 8150, 8120, like all of the FX chips. Because the thing is, they all like it would be, in my opinion, it would be really cool to have an 8 gigahertz validation on every single FX chip ever made. Just as kind of like, it's really dumb, but it would be kind of neat, right? To just have a bunch of 8 gig validations like that. And also, like the 8150s and the 8350s are just, they're just interesting. So I want to mess around with that. The thing is, also, I think with the 8320s and the 8120s and I think there was even an FX 8300. I think the biggest difference between and there's also like 8370s and 83, I think there was an 8370E. But anyway, I think the big thing with the different FX chips and like their different speed bins, I don't think it's super indicative of the 8 gigahertz capabilities. I think it's more about like core consistency. Because I think like the A320E has like a 700 megahertz spread between the best module and the worst module. And I'm pretty sure this 9590 isn't as bad in that. I think this is probably like 500 maybe. I don't know that it's like I don't think all the cores do 8 gigahertz. I think the only actually yeah, it's only the first core that did 8 gig, but the other cores I think I had at 7.9 each. So this thing might be like 400 megahertz variance instead of 700. So I think the big thing with the different FX bins is the core consistency. And the annoying thing with the 32 nanometer AMD CPUs is that you can't really pre-test them at ambient, because I tested a bunch of like 6420Ks, I think it was, which is admittedly not AM3 Plus, those are FM2 CPUs, but I tested them on water cooling, and every single one of them would do like 5.4 gigahertz or even 5.5, 5.45. Like they would do really high frequencies on ambient, and then you took them on LN2 and they just hit a brick wall at 7.6, which was like, what? And then you have FX 9590s. Like my first FX 9590, which did 8 gigahertz, like it wouldn't really do over 8 5.2 at ambient. And then this chip was actually given to me by a fan of the channel. So huge thanks to the guy for giving me this amazing CPU. But yeah, this chip, I didn't test it at ambient. If I had to guess, this thing probably doesn't validate that well at ambient either, because it leaks so much power that at ambient it probably just runs way too damn hot. It's like, I wouldn't be surprised if this chip walls at like 853 or something, which is pretty low, because you can get FX chips that at ambient will validate like 5.5, 5.6. But then the thing I'm wondering about is like, are those 5.5, 5.6 CPUs even remotely, like, do they scale? Because I've had a bunch of 5.4 chips which didn't. It's just like brick wall at 1.95 volts. Like, and the thing is, this validation was at I think 2.08, 2.07, I think, something like that. Because at 2.1, this chip was actually so hot that it would like lose frequency. It was less and less stable as you kept raising voltage. So that's another thing. Like, I need to figure out some way to run this thing colder and with better power delivery, because this chip is insane, and it's one freaking core doing all of that. So yeah. So this was really fun. This was really fun. Um, and yeah, now I have like a motherboard to try upgrade. Hopefully, I'm actually successful with that, because most of the motherboards that I've tried to upgrade, the improvements were very negligible at best. Right? Like if we look at the Maximus 11 Gene that I did, where it's like, yeah, I managed to shave off like 20 millivolts of overshoot, which is like, well, that doesn't do anything. Um, So yeah, but the UD5 is going to be interesting because that's also like a completely different VRM. And then it would be nice to have a crosshair, original crosshair, or a first or original revision Sabertooth. Because that's the thing is like a lot of the FX boards, like there's multiple different revisions. I guess I could also try the ASRock 990 FX Extreme 9 that I have. So I have kind of a lot of AM3 Plus boards. Not enough though. Not enough. The thing is, I don't really like working with DDR3 era ASRock boards. They tend to be kind of weird to work with. Um, but yeah, so this was a cool score, and it's like this is the kind of score where it's like, ooh, there's so much stuff I want to try, and then there's the Threadripper stuff where it's like, if I never have to run this again, I'll be very happy, because this thing was so annoying. Um, So yeah, anyway, the whole reason I did all of this, ran all of this LN2 on these CPUs was actually because one of my doers doesn't have a cap. So basically I need to burn through the liquid nitrogen in that one as quickly as possible because without a cap, it doesn't hold liquid nitrogen particularly well. Like there's a bunch of, like my other doers have a cap and they'll, like if I leave them for like several weeks, there's still going to be most of the liquid nitrogen still in them. But then there's one of them where it's like, yeah, it doesn't have a cap. So that one ends up like boiling off super quickly. So I just want to use it up. And that was kind of the idea behind that. I failed at that, actually. I didn't empty it. Like, I really thought the 3960X would just completely empty it because it's a freaking 24 core and it should pull a ton of power. But yeah, not really. I think the problem was that I was spending so little time in actual benchmarks and spending most of it like trying to get into the operating system, which, you know, admittedly, I was constantly pulling the up and down, but it's not the same as when you have to like pour straight through a Cinebench run because it was just burning off the liquid nitrogen basically as fast as you could feed it. Um, so yeah. Anyway, that's kind of that. Like, I'm mostly excited about the FX stuff though. I also have a 6350 that I need to run. Um, Hopefully that chip does well. Hopefully it does 8 gigahertz. It's not particularly good at ambient, and it does seem to be pretty power hungry. Like, that chip was a pain to cool. Admittedly, it was on air cooling when I last ran it, but maybe it'll turn out like my 9590 where it just absolutely, like, chugs power but validates pretty high as a side effect of that, so that would be neat. But yeah, AM3 Plus is awesome. Threadripper isn't. Threadripper is I don't know, maybe with a different motherboard it would be better, but yeah, on the Creator it was just nonstop frustration. Oh, one last thing I forgot to mention with the Threadripper runs. The LN2 mode in the BIOS seemed to make things worse. Which was like the most annoying thing actually. Was just like I enabled the LN2 mode stuff and it like wasn't like it didn't do anything for the stability. If anything, it really felt like it was less stable. So ultimately, the settings that I ended up running, like in terms of the voltages and everything in the BIOS, it's a lot like my water cooling. Well, not even water cooling. I've not run Threadripper on water cooling. I only have an air cooler for it. But basically, the settings in the BIOS are like air cooling settings with really high VCore. That's like the only difference. It was just like how much VCore I was running into it. The memory settings. Oh, and I also wasn't running particularly high FCLK. It was like 1600 FCLK, but you know, high memory clock, relatively decent timings, SoC voltage at 1.2 or maybe 1.25, which I've run even at ambient because Threadripper's Infinity Fabric ambient at least scales really well with IO die voltage. On LN2, it doesn't scale with anything as far as I can tell. Like, I tried to go over 1600 and it would just get really upset. I think I might have a run that's at 1633. But yeah. So Threadripper was not fun, and I also tried really low Infinity Fabric ratios, but it didn't really change like thermal the temperature behavior for my chip. So yeah, super annoying platform to work with. Also, I don't think it helps that like my LN2 pot was just kind of holding on with faith with this like totally mounting hardware. Oh, wait, one last thing I forgot to mention. I also came up with this right here. for keeping the memory from getting wet when running the FX chips, because the big problem with the FX chips running full pot is they freeze through really hard, right? Like you can see this outer edge of the board is covered in frost. And so the frost is fine. It's the water buildup that's the real concern. And on most of the board, the board's plasti dipped, right? Like it looks like this. Actually, now it looks even worse than this. I've basically what I do with this board is because I just use this board for validation. So every time I get a validation on it, I just write it down onto the board. So there was my first 9590 over there. There's some Phenom 2. I think that was a Phenom 2 555. Then we have the 8320E. The 9590 is sort of down in this like off to the corner. Anyway, yeah, so the board's really well like plasti dipped and everything, but once this area starts freezing over, then that can cause some issues, and then obviously the memory stick getting wet can cause issues, but this works really well. The biggest problem with it is I only have this center part clamped down, so in the future I think I'm going to, I have a bunch of spare PCIe brackets from all the dead graphics cards I have, which is why this is just a, destroyed PCIe bracket. It's just I have tons of them. They're relatively stiff. They're also pretty easy to bend. I don't know what the material is, but yeah, they're not, once you get them into a shape, they hold it pretty well, but they're also pretty easy to get into a shape. So yeah, I'm thinking of making a second one of those so that I can clamp it over the outer edges, because what would happen with this is the center of the stick and actually most of the lower portion of the stick that perfectly dry after a run, but there'd be a little bit of frost buildup on the outer corners, so I kind of want to do two of these clips. And yeah, also the memory stick that I was running for this was a Samsung 1 gigabyte G-Die single rank. And you kind of want to run some low load, easy to run, very overclockable memory chip, just because sometimes, with the 9590, I was raising the BCLK 30 megahertz in the operating system, which, some memory sticks can get pretty upset. You want a memory stick that'll tolerate really big swings of memory frequency after you've already booted. You don't really want a memory stick where it's oh, if you change the frequency by 200 megahertz, it's going to crash, because yeah, that's also a real concern. So, but you also don't want a dual rank stick, because that can put more load on the memory controller. And, you basically, for validation, it's just minimize the load on the CPU, and then everything has to also be pretty happy at a large range of frequencies, because you never know what the CPU is going to want. I was also toying with the idea of running even higher BCLK and a slightly lower ratio to try get some slight even a little bit more frequency out of the chip, but towards the end of the session, Easy Tune stopped working again, and so at that point I was just well, I got my 8.35, so screw this. And yeah, the thing is, at that point I was I'm just fighting the problems of the motherboard and the software, and it's the software is fine, but it's just if I want to do this, if I'm gonna push it even harder, I think I may as well use a better board next time. So yeah, I need to set up the UD5, which I don't know how I'm going to find time for that, because E590 is coming up. So the next time you see this 9590 run might be towards the end of the year, considering how quick I am to get around to doing things that I want to do. But anyway, so there, that's actually the end of the video. Yeah, I got some good scores. Hopefully they're all valid. I don't know that they've been checked by the moderation team yet, but this should be simple. This is just save a validation file. There's not really much I can screw up about that. The Threadripper scores, I'm not sure, because that's the first time I was using Benchmate. And then Geekbench 3, the thing is, Geekbench 3 was just scoring kind of all over the place. So, I don't know. I don't think it's bugged, because I could replicate this pretty consistently, but it did take a couple runs to get it. So, yeah. And I've not run Threadripper enough at Ambient to know how it's supposed to score in Geekbench. Which is kind of weird. The thing is, I don't like working with Threadripper, because even at Ambient, it boots forever. Right? On LN2, it's even worse, but at Ambient, it already takes forever to post. And then on Liquid Nitrogen, it's not only does it take forever to post, it doesn't like posting. So, Yeah, there. Okay, I'm actually just gonna hit the stop button at this point because I think, yeah, I've said everything I wanted to say. Fun session. I'm really happy that I didn't. Oh, no, stop button. Just hit the damn stop button. Goodbye, guy. Wait, no, wait. We need to do the thing. Like, share, subscribe, comment. Uh, well, actually, I don't really care for your suggestions. But yeah, like, share, subscribe. Comments, questions are welcome. If you'd like to support what I do here with the channel, I have a Patreon. There's a link to that down in the description. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, the usual YouTuber merch. There's a link to that down in the description below as well. Both of those help out immensely with running the channel, so if you check them out, that would be much appreciated. And yeah, that's it for the video. So thanks for watching, and goodbye.